Hello and welcome to Sarat Chandra IAS Academy, where your dreams are our mission. This is Yatharth here, and today we are going to read about various different topics. So the topic that we'll be beginning the lecture with is supernova. So such things or such space-related things, especially. In the earlier lecture, also I told you about the Lagrange points, L1, L2. So they can be asked when we talked about the Chandrayaan 3 and Aditya L1, the ISRO's Sun mission. Next one. So such space-related things can be asked directly, that what is a supernova. Earlier questions have come about the neutron star, a white dwarf. Alright, what are pulsars? So please note down all these terms whenever you see, let's say if you are making notes, then create one line note for each or make a table if you are doing it digitally. That what is a pulsar, what is a comet, what is an asteroid, alright, what is a meteor, what is the asteroid belt, what is a supernova, what is a black hole, what is a neutron star, what is a white dwarf, etc. etc. So all these things are equally important. Okay, so let's move forward with the supernova first of all. So it's a rare and extraordinary event in astronomy where a massive star exhausts its nuclear fuel and collapses under its own gravity. The collapse triggers a violent explosion that releases an immense amount of energy, causing the star to temporarily outshine an entire galaxy. Alright, so it's a complex thing. So please remember the closest star we know, which is Sun. So we'll see the life cycle of Sun also. It will also eventually collapse onto its own weight and develop a supernova. Alright, so supernovae play a crucial role in the evolution of the universe by dispersing heavy elements formed in the star's core and contributing to the formation of new stars and planetary systems. Please also see how new planets or stars are formed. A supernova is a rare, so we have already seen this is a repetition of the slide. Okay, so stars reach the end of their life cycles due to the depletion of their nuclear fuel. So what we need to see is, why do stars ever reach the end of their life cycle? So this is the same as everything. Everything has a life and it does end. And the basic answer to this whole problem is entropy. So entropy is the nature of universe, nature of things, that there will be an increased disorderliness in whatever is formed. Alright. So eventually, a star also collapses under its own weight. Because of what? It expends completely its nuclear fuel, and the balance between the inward force of gravity and the outward pressure generated by nuclear fusion reactions within their cores. The life cycle of a star depends on its mass. Here's simplified explanation, let's see. So mean sequence stage, alright. So this is the beginning of the, let's say, end of a star's life. So a star begins its life as a main sequence star, where nuclear fusion reaction in its core convert hydrogen into helium. So as we have already seen that in the sun's core also, in the last lecture we read about sun's layers. Alright, so in the core there is nuclear fusion taking place. Please don't confuse it with nuclear fission. Fission is heavy elements into lighter ones. Fusion is light into heavy. Okay. So nuclear fusion reaction core convert hydrogen into helium, releasing energy in the form of light and heat. Okay, then there is depletion of hydrogen. So star fuses hydrogen into helium, automatically the lighter element, which is hydrogen, it will reduce the core contacts due to gravity, causing it to heat up. Just a second. Okay, I hope you are all familiar with the equation PV is equal to nRT. So these things depend upon each other, whether it is temperature, volume, pressure, etc. Alright, so whenever there is a reduction in the, let's say, volume, the pressure will increase, keeping the same temperature, etc. etc. Helium fusion. So in the higher mass stars, when the core temperatures become high enough, helium fusion begins further, converting helium into heavier elements like carbon and oxygen. So from here these elements come. This process releases energy further, counteracting the force of gravity and preventing the star from collapsing sometimes. There is further a red giant phase. This phase you must have heard about the sun. So during the helium fusion phase, the outer layers of the star expand, causing it to become a red giant. This expansion occurs because the energy produced in the core pushes against the star's outer layers. So basically everything is a play of gravity. So furthermore, depending upon the star's mass, additional fusion stages might occur, forming heavier elements like iron also. So now finally what happens? There is supernova. This is one of the last stages. So when a massive star collapses basically, exhausts its nuclear fuel, the balance between gravity and energy production is disrupted. Gravity wins and the core collapses rapidly. This collapse can trigger a supernova explosion, releasing an enormous amount of energy. Final can be a black hole or a neutron star formation. In the aftermath of a supernova, the core collapses further and can result in the formation of a black hole. So very high gravity, when a very high amount of mass is condensed into a very low volume, the mass is says to be infinite and volume is said to be infinitesimal, very small. So it will form a neutron star or a black hole depending upon the star's original mass. If the mass is very much, then it will be a black hole. If not so much, then it may become a neutron star. Alright. So what is the white dwarf or planetary nebula? So in the case of lower mass stars like our sun, they expand into red giant and eventually shed their outer layers to form a glowing shell called a planetary nebula. The remaining core collapses to form a white dwarf which slowly cools and fades over billions of years. Alright. So that would be white dwarf from the red giant. So this can be asked as a question that red giant and white dwarf, they are related to what? Which of these? Neutron star, sun's life, etc. etc. Okay. So let's see the life cycle of sun. We'll just see it very briefly. So lasted about 4.6 years main sequence which we saw. A red giant phase, it will come. Hydrogen its core depletes causing core concentration. Inner plates like Mercury and Venus engulfed. Earth experiences increased heat and radiation. This is the one of the major, let's say, phase the humanity is preparing for further. Okay. Helium fusion phase. So helium fusion into carbon and oxygen. Sun undergoes periodic pulsation shedding layers. So this will be a very harmful phase for all our solar system. Furthermore, planetary nebula and white dwarf. So sun outer layer ejected, forming a planetary nebula. Alright, remaining core contracts to become a white dwarf and primarily composed of carbon and oxygen. This is main important point, that white dwarf is primarily composed of what? Carbon and oxygen. Cooling and fading. So white dwarf cools and fades over billions of years, eventually become a black dwarf, emitting minimal light. One type of question that can be asked in this is, let's say white dwarf, black dwarf, planetary nebula, and one more stage you can take from here, any, let's say red giant. So arrange these in the order that they are supposed to come. So red giant, then planetary nebula, then white dwarf, then black dwarf. Alright, so please remember all these things. What happens that we are not prepared, we always prepare as per PYQ. Alright, and standard sources. So UPSC will give like 1 or 2 questions from extra sources that we are not prepared for, and we will prepare it next year. Okay, so why wait for next year? Prepare it this year itself and learn about these small things. They are part of our solar system and universe. Okay, so at least learn about the sun and the earth. So this was a major life cycle of the sun. Okay, furthermore, let us see. This we have already seen. The stellar nebula, star, red giant phase, red supergiant, pulsation phase. Okay, shedding the outer layers, planetary nebula and the core. Core will become the white star and white dwarf, sorry, and then further move to the black dwarf. So at least 4.5 billion years more. Okay, so a lot more years. Okay, now let's come to the geography portion. Lake Titicaca. Alright, that is related to our GS1 geography. Mapping. So very important lakes of the world are very important, and this lake is here, Lake Titicaca, between the countries of 2 countries. One is Bolivia and second is Peru. Okay, you can remember this as BP or whatever, however you like. BTP or BPT. Okay, however you like, you can remember this. So, I hope you have all seen in the map. This is a lake here, Lake Titicaca, between Bolivia and Peru. I hope you all recognize this already. This is Latin Americas or Southern Americas. Okay, Argentina, Chile, all you can see here. Venezuela, Colombia, Brazil. Okay, so let's go further. So Titicaca is situated in the Andes. This Andes is what? Mountain range on the border between Bolivia and Peru. Is facing historical low waters. Very repetitive theme, historical low waters. This year also it came. Ramsar sites came. Alright, freshwater lakes came in the first question only of geography. So only 10 inches away from its all-time low recorded in 1996. So introduction, let's say. So it is nestled in high elevation in the Andes mountains. It stands as one of the world's largest and highest lakes, with a surface area once spanning over 3,200 square miles or 8,300 square kilometers. This is a very, very big area. I hope you all understand this. Just a second. Okay, so 8,300 square kilometers. So how big is that? You think about this. It is about 83 by 100 kilometers. Alright, so it's very big lake. This remarkable natural wonder occupies a significant place in South America's geography, ranking among the largest lake in the continent. So it holds a distinctive position next to Venezuela's Lake Maracaibo and Brazil's coastal Lago dos Patos. So it's a very big lake, almost like a sea, small sea you can say. Okay, changing water, sorry. So in 1986, Lake Titicaca's water level reached an apex, surging to an elevation of 12,504 feet or 3,811 meters above sea level, towering over its present level. However, this surge was short-lived, as by 1996, the water receded to 12,491 feet above sea level. Okay, so there's been decrease of 12-13 feet in such a big area, 8,400 kilometers square kilometer area. So that's a lot of water. Okay, the fluctuation attributed to the effect of climate change paint a discerning picture for lake's future. Disconcerting picture for the lake's future. So think about it, 13 to 14 feet from 8,400 square kilometer. So what kind of volume that would encompass? And that is all because of the climate change. And this thing is repeating now. So this question can come directly. You can also use this example as a case study. So please note down this Lake Titicaca, what happened in 1996 and what's happening now. Note down the recession. Note down the area of the lake. And if you can figure out, then figure out how much water was receded. So it's the manifestation of climate change compounded by a series of meteorological, hydrological and climate factor. Meteorological, that means weather related. Hydrological means related to water directly, and various other climatic factors. The lake's reliance on rainfall and inflow from Peruvian rivers has been affected. Okay, so you can see the slope, with reduced precipitation leading to an inability to attain normal water levels even during rainy seasons. Climatic phenomena like El Nino and La Nina, both of them I have covered in previous lectures. This is an El Nino year for India. For India, it is an El Nino year. Earlier was La Nina. Last 2-3 years was La Nina phase. So how El Nino will affect India? Lesser rainfall and more temperature. Alright. So distorting established pattern of rain and drought over time. There is our environmental stresses also. They have, beside the sprawling city of El Alto, home to a million residents, has contributed to severe pollution of its waters. Indiscriminate fishing practices have endangered species, further unsettling the lake's delicate ecosystem. If there is no ecosystem, okay, the lake will eventually die. So how do lakes or water bodies die because of lack of ecosystem? You must have all read about pollution as well as BOD and COD. If the pollution is inside coming, let's say, then the fish will die. Once the fish die, the BOD also increases as well as the COD also increases due to excessive nutrition and pollution. Okay, then there is a growth of plants here. Then there can be an algal bloom. Once there is algal bloom, then the water body is gone. It's dead. Okay, the ecosystem is very, very hard to restore then and almost impossible. Okay, global concerns and local despair. So as the situation is intrinsically tied to climate change, addressing Lake Titicaca's predicament. What is predicament? Predicaments mean problem. Demands a global response. The Amazon Cooperation Treaty Organization, so ACTO. Recent summit in Brazil. So this can also be asked that where was the last summit or recent summit of ACTO held? So it was in Brazil. Okay, it is the biggest rainforest, and Amazon is the biggest river in the world. The longest is Nile. Okay, so emphasize the responsibility of industrialized nation to provide resources for climate change mitigation efforts. Despite these calls for international cooperation, the communities surrounding Lake Titicaca are grappling with the reality that their cherished lake might never regain its former water levels. So just like everything I told, just even if the sun can die, alright, so what is Lake Titicaca? It may also as well as die. And what is Earth? Previously there have been species which were so invincible, like dinosaurs, they also vanished. So humans will also vanish. But what we can do is to have a good sight towards the future and try to protect not only ourselves but also our home, which is Earth. So I hope every one of you is contributing least and least towards the pollution, trashing and all. Okay, let us have a look at the Great Lakes of the Earth, or the important lakes of the Earth. So this is what we talked about, Lake Titicaca here between the Bolivia and Peru. Alright, so whenever you see any lake, you can point out that water level is falling, let's say. Then water level falling. So this is the main issue related to Lake Titicaca. Okay, this is Caspian Sea, located here. Aral Sea, located here. Lake Tana, this from here one lake came into the prelims 2022, Lake Fagubine, because of the same issue, falling water level. Okay, Lake Tanganyika, Lake Nyasa, Lake Victoria. Victoria is a very big lake. Lake Turkana, Lake Tana. Aral Sea we have already seen. Lake Balkash, this is in Russia. Lake Baikal, this is also in Russia. Lake Ladoga. In India, you can especially see there are many freshwater lakes which came into the question, and you are supposed to specially read them all, especially freshwater Ramsar sites. Okay, question came from Dal Lake this time and many other lakes. Okay, Lake Vaman, Great Lakes. There are 4 lakes here which are known as the Great Lake of USA Americas, Lake Superior, etc. So you can read about them. Then there is Lake Winnipeg, Great Bear Lake. This is in Canada. Great Slave Lake, Lake Athabasca, and Great Salt Lake. This is also here in Americas. So you can see and map them all. Alright. Let me also tell you about the Great Lakes. Just a second. Okay, so Great Lakes are these ones. There are 5 lakes. They are Lake Superior. The other one is Lake Michigan. There is Lake Huron. There is Erie and Lake Ontario. So what 2 things you need to remember about them? One, they are all interconnected. Second, they are all freshwater. And third, they connect to the Atlantic Ocean. So how do they connect to the Atlantic Ocean? That is also a question. They connect via the St. Lawrence River. Via the St. Lawrence River. Okay, there are Lake Albert and Lake Malawi also here. Lake Nyasa or Lake Malawi. So almost all we have covered, important ones. There are more, we'll be covering them later, maybe in another lecture. So this is Yatharth here, signing off. Thank you very much for watching. I hope you enjoyed. If you have any suggestions, you can let me know in the comments. Keep studying, be bright, and have a very good day ahead.